my students at the start of our lessons as we wait for everyone to connect and just the final like stragglers and latecomers. And this is because, I mean, in my physical classroom, I've always believed in the power of humor. And I didn't really want that to change when we moved online. If anything, I thought it was possibly more important, as so many of our students are anxious and stressed out. So we have one or two jokes. We laugh about how good or bad they are, and then we settle down for a session of learning. And so what does that typically look like for my class? So for us at Eklund, as has been said, we use Google Meet as our video platform. And I will start my lesson, as John said, with cameras on. So my camera on, my students' cameras on, so that everyone can see each other and we kind of make that virtual connection at least. I use Google Classroom to upload all my resources and post assignments, and these come on before the timed start of my lesson, so that students, if they wish, can already log on and have a look and see what the instructions are. I again reiterate the fact that I understand that we are in a privileged position, being a device school. Lots of our students are quite au fait with a lot of the technology that we use, but that wasn't always the case for me. I came from a school where we did not have access to lots of computers within each individual class, lots of students with varying needs at home, and so it was a big change for me. But I learned that with communication with colleagues and being willing to learn new things, that it was going to be okay. So if I can do that, I think we'll all be okay, I hope. So a typical lesson for me starts with a check-in, a wellness check-in. Students share the jokes, talk about positives or things that they want to improve from the remote learning experience in general, or for my classes in particular, or just share how they're feeling. We put all the instructions on Google Classroom, and that tends to be a set format. We use a main PowerPoint with a video or a link to a podcast or an article that kind of delivers instructional content. Then varied tasks to get them working with that content, get them working with those ideas, creating mind maps, diagrams, summary notes, where possible working on Google Slides or Docs, or using printable worksheets if they've got access to printers at home. So I'll introduce the topic, give them kind of my explanation time, but I try to minimize that. So as John said, I'm not talking at the screen, and it allows them to be quite student-paced. They work through the slides, and then at the end of like a learning session, there'll be some kind of review, quiz or game, Kahoot, Quizlet, Google Forms I've been using a lot for both formative and summative assessments. I can talk on that more should anyone wish me to. So here's an example of what my students would see on a Google Classroom page. So here I've got a recap PowerPoint. This was one of the first sessions we had remotely. It was in the middle of a genetics unit, but some of my students had already started self-isolating prior to the school closing, so they'd missed a few lessons. I just wanted to make sure that everyone was starting at the same point. Then we have the main PowerPoint for the lesson. I've found that one key concept, one main learning objective per session tends to work best for my students. And then here, as said, a review form, and I've told them it's not a test score. In these situations, it's purely for me to just kind of see what they get, what they don't get, what do I need to readjust. And so my feedback from my students so far has been that they really like the structured nature of the lesson. It allows them to work independently, but they know that I'm still online and they can ask me questions in the chat on Google Meet if they stay online. If they have connectivity issues, they can have the PowerPoint, they can go and work off independently. and drop me an email. And my email is always open during lesson time, and they can check in that way. And it just allows me, if they're working on a document that's like a Google slide or a Google Doc, I can see what they're doing. If it's all linked through the Google Suite, I can see what they're doing. I can give them real-time feedback, pick up any misconceptions. I know if I need to bring everyone back into the Google Meet and talk through something, all the kind of normal teacher things, but just remotely. And I think they're enjoying it. They find it productive. Feel like they're progressing. So whilst I have this general template of an online lesson structure, there still needs to be variety in the methods of information delivery. And so wherever possible, I get them using interactive resources. TED-Ed videos, animations, Radiolab podcasts, Vision Learning has lots of kind of textbook-like resources. And what's great about each of these is that they either have integrated questions linked within them, or it's quite easy, hopefully, to set up a Google Doc, a series of questions that students can work through as they are engaging with any one of these resources. There are also countless simulations out there that we actually already use in class that are really easily transferable to obviously an online situation. We use a lot of FET Colorado simulations. Learn Genetics Utah has lots of step-by-step either content to just work through or like interactive building DNA structures, etc. Concord Consortium, I've used recently for looking at diffusion with my year 9s. And actually previously, in a previous unit, before we moved remotely, I've had students using virtual field trips and cameras and things that lots of zoos around the world have available to look at animal behaviors for some of their own lab reports. So I don't see any reason why this can't continue in this online setting. So it's obviously really important to not lose the key aspect of science learning, which is practical work. And while simulations are a really good alternative, it's still really important to me to see where I can bring in home demonstrations and home labs. And so we obviously spend a lot of time in traditional classrooms using models to make concepts clearer. And with a bit of imagination and creativity and support from parents, it can actually happen in the home. I have students modeling osmosis using eggs, vinegar and salt water. Salt water can be used to have them kind of doing a mini chromatography lab, using thick paper and like coffee filters or pens and candy. And actually candy and sweets are great in general for building models of atoms, DNA. We do this in class. If they have those available at home, they can construct these models themselves. And if they keep everything clean, I see no reason why they can't then eat their models at the end. But what's important with these ideas is that it's not just, I mean, even if they're trying to blow bubbles in their kitchen, trying to show how it can resemble the features of a membrane, it's that they use these models and find some way to document their ideas based on the justification and the evaluation of these models. So they're still developing their key skills and consolidating content knowledge just remotely. And taking it further than just creating models, students can still run full investigations at home. So as many IB students do anyway for their IAs. So last week, I just had my year 9s in their final lesson, starting the topic of motion. We introduced the relationship between speed, distance, and time. I tasked them with finding out how the height of a ramp would affect the speed of a ball or a car rolling down the ramp and moving a fixed distance, as you can see on the image. And I told them the basic equipment they would need. They were given a simple results table to fill out. This was all through a Google slide that they each had a copy of for themselves. And I was very surprised by the number of students who had random planks of wood in their homes already. Great. But also for those who obviously didn't, it was lovely to see how proud they were of figuring out ways to use what they had to create this lab for themselves. They would turn their cameras on, get fixed on their ramp building spaces, and they were using skateboards, ironing boards, rulers, folders, books to build their ramps. And actually, I couldn't have asked for a greater reminder of this not being a normal situation when I saw one student on camera use their dog, deciding that the ball that was rolling down the ramp was an indicator for playing fetch. So that was great. But because they're all doing these things differently, it actually makes for really good discussion points around variables, how best to collect reliable data. So I could unmute students, ask them probing questions. Why are you doing that? What is that? How is that going to benefit you? You can watch them through trial and error, realizing that something like they need to increase the distance to be able to give themselves enough time to react and start the timer on their phone and stop the timer on their phone. By the end of the lesson, they were all able to collect some data. Not groundbreaking science, but a fun way for them to think about the fundamental parts of a science investigation. And I had a simulation ready in case anyone couldn't find anything, but we didn't need it. And so this was a relatively simple example, but it was, you could scale it up so that they do a full lab report and they come up with a research question for themselves with things around in their home. So they're still developing their science skills. But even when they do a full lab report, that doesn't have to be a traditional written document. What's to stop them from making a video report or a scientific poster? I have, in fact, previously recited a spoken word poem about action potentials to my year 11s before. So they know that I love things that are kind of out there a bit. So it's about letting them be creative and communicate their ideas in a way that works for them and what they've got available. And linked to that idea of creativity. So you've might finished a big topic or a unit, you want to bring things together, or you are in a situation where you do have a lot of connectivity issues and you need a lot of asynchronous learning opportunities. Something that's, two things I want to share linked to that are science choice grids and learning mats. They're essentially one and the same. I've used variations of these before as plenaries, tasks, as revision exercises, and they're really easily adaptable to kind of being home learning packs. So here's an example of one I found on TES, and I'm going to adapt for my classes. So this could last a student an entire, it's actually two sides, this could last a student an entire term. There's a wide range of activities from simple, ranging complexity and challenge. You've got a simple write a tweet, so they've got to be super concise and summarize an idea. It can be a science skill, it can be a particular concept you want them to focus on, to creating a movie trailer or a crossword or any, so they get choice, they get autonomy over their work, and they get really engaged with things like this because they are picking what they want to do. You set parameters, obviously. You can say, I need you to have had a full meal of starter, main course, and a reflective dessert within 2 weeks. And you just need to make sure you've got some way of checking in with them or letting them log their progress. It could be a diary, making a note in their workbook on either on paper or online, talking to you about it when you have your video conference chats, or some people have said about WhatsApp groups, anything that just lets you check in with them. So, and that's here's another example of a choice being used as reflecting. These are all general science ideas. Again, you can use this for as long as you need, you adapt it. And this one is more specific to a very fixed topic, but again, they can pick what they want to do. You set the parameters. So we've now had 3 weeks of remote learning, and we obviously have to prepare like this could be going on for a good while longer. So moving forward, it's about finding a balance. Lots of people have spoken about well-being, and so it's about finding that balance between maintaining academic rigor and challenge for students, because they do want to feel like they're doing purposeful work, but also appreciating that they're going to feel overloaded a lot quicker in this novel learning environment. So I ask my students regularly for feedback on our bio lessons and our science lessons in particular, and I plan on taking that and adapting it over the Easter break coming. So that key things I'm going to be doing: streamlining the number of tasks within a standard learning content lesson. They don't need 4 worksheets linked to something. If there's a way that I can have it all on one set PowerPoint with minimal extras, that's great. Less can often be more in this situation. As has already been said, I want to record some screencasts, so pre-recorded explanations of key ideas. No one knows your students better than you do in this situation. So yes, videos, online YouTube videos, I use a lot of them, but I know that my students would appreciate hearing from me when they need to understand something better, especially, just like Kerry Lee said, if you do have access to good video tech and you can share screens and use interactive whiteboards, great. My laptop has a stylus pen, so I can draw on my smart whiteboard as I share my screen and they can see that. But not every laptop obviously has that, not everyone has that available to them, and it's still obviously not the best, but we're working with it. So recorded explanations is something that I want to go through, and looking through my unit plans and coming up for each of my classes, just finding little spots where we can use independent interactive tasks, even better if they're offline. And I'll just briefly touch on assessment. Just as John mentioned, I used Google Forms to do lots of formative assessments after each specific learning topic or concept. And then just this past week, for my year 11th, we did a summative assessment on genetics, and it actually worked quite well. It was on Google Form, series of questions, mostly multiple choice, a few that they typed an answer directly onto, and then some where they actually wrote on paper, took a picture, and then uploaded that. And I agree with John that you can use these, and it's just about thinking about the type of question that you're going to put on there, so that you're making them think. It's not just an obvious, lots of people think the multiple choice is easier, but if they're really having to work through what the different problems are, they're not going to doesn't lend itself to cheating or that kind of thing. So so that worked really well. So I'll be trying to do more of that. And just to come to a close, I found this quote recently, and it struck me that we can actually use this opportunity to model the traits of good scientists for our students. We can model the skills we expect them to have. We're doing this right now. We are problem solving, we're communicating and collaborating. Someone said about being flexible. And we ask our students to work together regularly, and I am genuinely really glad that we are doing the same. So to summarize, I hope I provided just a few ways in which science lessons can be structured for remote learning, with both kind of online and offline ideas that hopefully still allow for deepening understanding, developing science skills, and I mean using anything and everything from simulations, podcasts, virtual visits to the zoo, all the way to having like students blowing bubbles in their kitchens or building ramps in their living rooms. And lastly, I think it is really important to remember this. We're all in different contexts. We're all got different situations, and we can only ever do as much as we can. It's not just what we have, it's what our students have available to them as well. Each of our students are going to be in different homes, situations, resources available. So we must be patient, flexible, and just do what we can with what we have. So I will close there, and if anyone has any questions or specifics, wants me to talk about anything more, I can do so. Thank you. Hope that was